Hi, and welcome to Papetti Math's YouTube channel. That's me, Mr. Papetti, and today I'm going to be teaching you how to find the zeros of a quadratic by completing the square. So it would be helpful if you watched the videos from Lesson 2 and Lesson 3 before you started this video. So if you haven't done that, you might want to go back to my YouTube channel and try those out now. If you have done those, then we're going to continue with the same ideas that we used in lessons 2 and 3 to find the zeros now by completing the square. If you remember in lesson 2, we did the whole process of completing the square to put it in vertex form. And then in lesson 3, we simplified square roots and we saw what it meant to be in simplest radical form. So today we're going to combine both of those ideas together to not place a quadratic in vertex form, but to get to that step and then solve by completing the square. Up until this point, you've only seen how to find zeros by factoring a quadratic. And factoring only works when you have integer solutions. So these many times will not be integer solutions, but they might be decimals or answers in simplest radical form. So let's get started in exercise number 1. It says to begin by finding the solutions to the equation below using square roots as inverse operations. Express your answer in simplest radical form. So if you have x plus 2 squared minus 8 is equal to 0 now, we're going to want to isolate this x by starting from the outside and working our way into those parentheses. So let's take a look at this equation and think about what we could do first. Well, we have that minus 8 on the outside, so it would be helpful if we could undo that minus 8 right there. So we'll add 8 to both sides so we could get inside those parentheses. So we're going to have x plus 2 squared. The minus 8 and the positive 8 will cancel out, is equal to 8. Now, before we can get inside those parentheses to get that x by itself, we're going to want to undo this square. We want to remember that the way we undo a square is we take the square root of both sides. So if we take the square root of the left side, we'll be left with x plus 2. And if we take the square root of the right side, well, 8 is not a perfect square. So this is where we're going to want to simplify this square root. So over here, we'll make a prime factor tree for 8. And 8 can be simplified to 2 times 4. The square root of 2 times the square root of 4 will give you the square root of 8. Circle your prime factors. And 4 will be square root of 2 times the square root of 2. All right. So now that we have a prime factor tree, we could go back to our problem and we could set up our radical. And inside that radical and outside that radical, we want to put pairs on the outside. We want to put singles on the inside. So we want to cross off a pair of 2's. And when we cross off the pair of 2's, we write 1, 2 on the outside of the radical. And we have a single 2 left over. So singles stay on the inside of the radical. It's just plain old 2 right there. So the square root of 8 simplified is the same thing as this 2 times the square root of 2. And we always want to add that plus or minus. So the last thing we want to do is we want to subtract 2 from both sides to get this x completely isolated over here. And we'll have x equals, now I like to put this number first and then the plus or minus radical. So I'm going to do negative 2 plus or minus 2 radical 2. So this is all I could do with this one because remember, you can only combine like terms. So these two are not like terms because there's no radical 2 on this negative 2 over here. If this had said negative 2 radical 2 plus 2 radical 2, then you could do something more with that. But since one has a radical 2 connected to it, and this one does not, they're not like terms, and this is all you can do for this problem. So this would be your answer in simplest radical form. So if you notice, it says right at the bottom that this equation was already in vertex form. So this is what we placed in vertex form in lesson 3. Nope, excuse me, in lesson 2. And in lesson 2, we got to this point right here, and now we just solved it. So what we're going to do first in exercises number 2 and so on, we're going to have to put them in vertex form first in order to solve them. That's all for this video.